Hi guys, my name's Professor Martinez, Esmeralda Martinez. If you haven't read my introduction on our discussion board, please go read that. If you have any more questions like about me beyond what's on the discussion board, just ask me. Feel free to ask me and I'll answer you guys. So we're gonna go over chapter 1 in this video, and I want to point some things out. So I want to establish some guidelines about each lecture video in general from here on in the future. So I'm going to be addressing major topics from each chapter in each of these videos. So unfortunately, what that means is that I won't be covering every single thing in each PowerPoint in great detail. So the good thing about that is that these videos won't be that long. But the bad thing is, I don't get to talk about everything the way that we would in a face-to-face class. To help counteract that, the fact that I don't get to cover everything myself in videos specifically, is that I'm going to be posting like supplemental YouTube videos. So I will find good videos on YouTube, most likely Khan Academy, and I'll post them as links on Blackboard in whatever week we're on. So this week specifically, just to give you an example, I'm going to be posting a video over the scientific method and also over scientific notation, so that you guys have a good source to watch on your own time if you aren't familiar with those things already, and if the slides aren't enough for you, like if you need somebody to help you to explain that. So in general, from here on out, just know those things. And the reason for that is because I want to focus on what I know is most difficult, and specifically what I want to explain in my own way. And then just to give you a heads up, there's material, so topics that I'm going to cover, and then there are problems that I embed in my slides. Those problems are either titled examples or they're titled on your own. If they're titled examples, I will work them out on screen and explain them. If they're titled on your own, that means I'm not going to include them in the video, but we will go over them. Hopefully you have already covered them by then, like you have already tried to work them out. We will go over them in the live problem solving sessions. So you will see that video posted. You will either attend that live or you will see it posted later on in the week. So to start this chapter off, we're going to talk about why we're studying chemistry in the first place. Now, the number one answer from students specifically is that they need a science class and they don't like biology, they don't like physics, so they end up taking chemistry. And I mean, that's okay because you end up in my class, right? And I like that you guys are taking this class. But as you keep studying science, if you're a science major, you will end up seeing that chemistry really does relate to everything, especially things in your daily life. So another reason we're studying chemistry, and this is something that I personally am very passionate about, is so that you guys don't fall for things like this. By things like this, I mean these types of claims. So I want you guys to open these links up. I'm not going to open them up, but I want you to open them up, just scroll through them, see kind of what they're about. This first one, all it does is it takes the chemical name of water, like the proper chemical name of water, and it makes these scary claims when in reality none of it is kind of true. And this second one is advertising these chemical-free products and having a chemical-free home, when in reality that is impossible. Not only is it not true, but it's impossible. Everything around you is made up of chemicals. Your hair, your skin, your desk, everything, your phone. Your skin is made up of keratin and collagen mostly, and both of those things are made up of amino acids. Amino acids are made up of carbon, hydrogen, nitrogen, oxygen. So there's no such thing as something being chemical free. So a big thing that I like to stress in this class is kind of just using this class to be a smarter shopper, to be able to pick up on things that are just complete bogus. Especially in marketing, they really take advantage of the fact that not everyone has a good chemistry education. So the main goal of this class is that we are going to be able to understand the substances around us. So to start talking about the actual chemistry topics, we're first going to talk about matter. So matter is anything that occupies space and has mass. Now, if you're confused about what has mass means, all that means, or the way that you can think about it, is that you can put it on a scale and it'll have a certain weight associated with it. And we actually have 3 states of matter that we are going to study. There is a 4th one called plasma, but don't worry about that one for this class. We're not going to deal with it. But the 3 that we're looking at is solid, liquid, and gas. I'm sure most of you know these, but just to reiterate what the properties of them are, solids are rigid. They possess a definite shape and volume. So they have a certain shape and volume. It's not going to change unless some sort of physical change is applied to it. Non-compressible liquids are somewhere in between solids and gases, so they can flow. They have a certain volume, but they will take the shape of whatever container it's in. They're non-compressible, and then gases are kind of on the other end of the spectrum, so they're very flowy. They take the shape of whatever container it's in, and they're very compressible. So to illustrate this term, think about just a gas tank to fill up like balloons with helium. That gas tank can be pretty small, right? But you can fill up a lot of balloons, and that's because the helium gas inside of that gas tank is very compressed. It's very, it takes up a little bit of space. So this diagram is showing you the 3 states of matter and how they look like at the atomic level or molecular level. So here in solid, you can see that they're very rigid. They have a certain structure to them, the atoms. In liquid, they're kind of more less organized, obviously. And then for gas, they're just very far apart and way less organized compared to solids. So earlier I described how you can think of mass as something that you can put on a scale that you can weigh. So I want to first clarify the difference between mass and weight. So mass is the amount of matter in something, which I know sounds repetitive, but once we talk about weight, it'll probably make more sense. So weight is affected by gravity. That's the major difference between mass and weight. Mass stays the same wherever you are, whatever the gravity is. So if you're on Earth, you're 63.5 kilograms. You're on the Moon, 63.5. Jupiter, 63.5. The Sun, 63.5. But your weight, if you notice, is different on all of these planets. So the more gravity you have, the higher the gravity, then the more your weight is going to be affected. So you're going to have a higher weight. So this is just a little diagram to help you differentiate between the two. Basically, mass is not affected by gravity, weight is. So these are 2 very important terms that you are being introduced to pretty early on in the class. Later on, you will learn a lot more about what these 2 terms mean and just more details. But for now, just know that atoms are basically your building blocks for matter. Keep it that simple for yourself right now. In nature, you don't really find atoms by themselves. What you actually encounter most often are molecules, and molecules are just more than one atom, and they're connected by something called bonds. And you can think of them as a unit. So whenever there are things that are bonded together, they don't move separately and then come back together. They're always a unit. You can think of them like people in a wheelbarrow race. So I want to remind you guys that I'm not covering every single slide, but the other slides are important. The reason that I'm only covering certain slides is because it gets a little bit repetitive. Like I might have definitions on one slide and then I'll have like a summary slide, for example, this one. So I'm going over the summary in hopes that you have already gone over the definitions or that you can refer to those definitions if you need more explanation. So here, this is showing you like a little like guide to determine whether something is a mixture versus a pure substance. So matter can either be classified as a pure substance or a mixture. If you're a pure substance, you're either an element, so the fundamental building blocks, or you are a compound. And I'm saying you like if they're alive, or it's a compound. And a compound is just a certain type of unit of atoms put together. And if it's a pure substance of this compound, then only those exist. So for example, you have a glass of water here, and it only has water molecules in there. It doesn't have anything else. Now, if you have variable composition, then that means it's a mixture. The easiest one of these two is the heterogeneous mixtures. So heterogeneous mixtures, you can very obviously tell that it's composed of two separate things. So for example, when you have like very sandy water on the beach shoreline, you have rocks, you have water, you have sand all mixed in. You can see the sand, you can see the water, you can see the shells, you can see the dirt, you can see that they're all different. So obviously it's a heterogeneous mixture. And then homogeneous mixture just means that it's very uniform. You can't really see the difference between what makes up this mixture. So in this case, we have tea. So in this tea, you can have sugar, you can have the caffeine from the tea, you can have whatever other components make up the flavor of the tea, you have the water molecules, so you have a bunch of different things, but you can't really see that it's a mixture. And that's why we call it a homogeneous mixture. So not all elements exist as just that one element, like one atom by itself. Some elements exist as diatomic molecules or as polyatomic molecules. Now specifically, I want you to memorize these right here. So, and I have an acronym which a student, I think that student found it on the internet already or he made it up, I'm not sure, but it's an amazing acronym because you'll never forget it. Have no fear of ice cold beer. So all of these elements, hydrogen, nitrogen, oxygen, fluorine, iodine, chlorine, and bromine, these all exist as diatomic. So that what that means, di means two, and then atomic, two atoms, molecules. So instead of just being atoms, elements, they're diatomic molecules. So it's very strange, but just know that these exist and specifically memorize these right here. Now, I do want to point out that sulfur and phosphorus exist as polyatomic molecules. So sulfur exists as S8, you can see it right here, and then phosphorus exists as P4. I don't think these are as important, but just recognize these when in the future when we start working with chemical reactions. Just know that what those are, polyatomic molecules and diatomic molecules. So now that we have a better idea of matter, how we classify matter and what atoms and molecules are, we can actually start to describe the properties, so both the physical and the chemical properties of substances. So physical properties have to do with anything that is not affected by its chemical composition. So for example, things like odor, how it smells, how it tastes, the color of it, how it looks, melting point, boiling point, and density. So these are things all associated with the substance itself, but not necessarily what makes it up chemically. So what atoms and what elements it has inside of it. Now, whenever you have a physical change, that means that none of the chemical composition will be affected. So a good example is whenever you boil water. So here you have a pot and you're heating it up. As you're heating it up, the fire is making the water molecules kind of move faster, and eventually they move so fast and they get so hot that they come out of being a liquid and they turn into a vapor. So they change from being a liquid into a gas. So this is a physical change because the water molecules aren't affected. So you can see here there's still water molecules. They're still the same little water molecule, except it goes from being a liquid to a gas. And here's some more examples. So sugar dissolving in coffee, it's going from being a solid into a liquid. Whenever you make a metal to something that is magnetized, so for example you take iron, and I'm not exactly sure how it works, but you make it so that it attracts other metals and it's magnetized, that's also a physical change. So for chemical changes and properties, the best way for you to remember that is that they are irreversible. So let's say you take a cake mix and you add the eggs and you add the water and the oil and you mix it all up and then you bake it. Can you take the eggs out of there once you bake it? No. So something like that, something irreversible, is a chemical change. Now, specifically, how likely something is to have that chemical change is what a chemical property is. So here you can see some different chemical properties like flammability, toxicity, acidity. These are how likely something will react and undergo that irreversible change. Now, just to give you some more examples of a chemical change besides baking a cake, car rusting. So whenever a car rusts, the iron that exists outside on the car, I don't even think there's cars with iron anymore, they're all plastic, but let's say you have an old school car that actually has iron and it sits outside for a very long time without like you washing and cleaning it. It's going to react with the oxygen in the air and it's going to turn into iron oxide. So that's a completely different compound compared to just iron by itself. So that's what a chemical change is. And always remember, like I said, chemical changes and properties irreversible. Physical changes and properties reversible. They can go back. So for example, that physical change we looked at, which was the the water boiling into water vapor. You can take that water vapor and condense it back into water and it's back to how it was. It didn't change at all. So that's a physical change. So a lot of physical changes you guys are probably already aware of. So for example, when water evaporates, so this is supposed to be like water or liquid. When water evaporates, it turns into a gas. When water freezes, it turns into a solid, which is ice. You can call that solidification or freezing, whichever one. Whenever ice melts, it turns into a liquid. So you guys know all of these terms. Two terms that you might not know of, which are very kind of uncommon, at least for us to see in everyday life, is sublimation and deposition. So sublimation is when a solid goes directly from being a solid into a gas. Not even, it just skips the liquid stage. And the opposite, the other way around, when a gas turns into a solid without turning into a liquid first, it's called deposition. So these are some final like classification type things about physical properties. So extensive properties. These are properties that depend on how much you have of the substance that you're looking at. So things like mass, volume, and heat are all extensive properties. So the more matter you have of something, of course, the more mass you're going to have, the more it's going to weigh. Just think of it that way. If you have more mass, it's going to take up more space, so it takes up more volume. Now, intensive properties are I feel like they're the ones that are harder to conceptualize. So the way that I remember it is intensive properties are independent of the amount. So that's why I have this highlighted right here. Intensive are independent of the amount of whatever substance that you're looking at. So things like temperature, conductivity, and boiling point. So I want you to memorize these extensive properties up here and these intensive properties down here.